Hello everyone. Today I'm here with lesson number 5, periodic classification of elements. Basically, classification means identifying similar things and grouping them together. We all classify the things, whether it's our books, whether it's our clothes, and classification of different species you might have studied in your biology also. So here we are going to study about the classification of elements, how elements are classified. You know that there are different types of elements: metals, non-metals, and metalloids, but they need to be classified somewhere in proper order and sequence. They are being organized in a periodic table, but how this classification has started and how finally we got this periodic table, we are going to study all this in the chapter. So first of all, let's start to see this periodic table. You all are aware with this periodic table. You all have seen this periodic table, and you can see how beautifully all the elements are arranged here. This one you can see, the green one, it is a block for metalloids. All the metals still here, elements still here, these are metals. These from here to here, these all are non-metals. Okay, and how this has been done, because it took so much of time and so much of inventions from different scientists to make a proper table that is known as periodic table. In this periodic table only you can see alkali metals, basic metals, halogens, noble gases, non-metals, rare earth metals, semi-metals or metalloids, and transition metals. Okay, and they all are showing different properties. They are arranged in their increasing order of atomic masses and all. So we will concentrate here how this classification has been done and how this periodic table has been made. So first of all, what is the need of classification? As you all know, it makes the study of elements easier, because elements are the building blocks of any substance, and there are 118 elements that have been identified till date, and among them many of them occur naturally. So it is not possible to study the properties of all the elements separately. Therefore, elements have been divided into different groups in such a way that elements in the same group have same properties. Okay. Then early attempts of classification. When earlier the classification was made by scientist Lavoisier, he divided the elements into two main groups, that is metals and non-metals. At that time only 30 metals were discovered, but later on when discovery started up with more number of metals, then that concept was not very sufficient for study. So different efforts have been made for making the periodic table. The first scientist who started up with this grouping and classification was Devonier. After that, Newland, then Mendeleev, and finally Moseley has constructed the final periodic table. So here we will study efforts of each scientist. What was their discovery, what were the main points of the discovery, and what were the limitations or drawbacks of their theories. So we will first start with Devonier's. Okay, Devonier was a German chemist, and he arranged the elements with similar properties, both physical and chemical properties, in a group of 3 called triads. 3 means triads. Okay. Now the basic arrangement was the atomic masses of the element. You can see here there are 4 triads in this type. So here he has arranged them in increasing order of their atomic masses, and he calculated that the atomic mass of the middle element would be the mean or the average of atomic masses of the first and the third element. Okay, so for example, Let's see here. Atomic mass of lithium, it's 6.9, and for potassium it is 39. If you add both of them and divide by 2, then you will get the value 23. That is the atomic mass of sodium. Same way, atomic mass of calcium is 40 and atomic mass of barium is 137. If you divide them, add and take the average of both of them, then you will get the average to be around 87.6. That is the atomic number of strontium. Same way he did for chlorine, bromine and iodine also. He was saying that the average of element A and element C will give you the atomic mass of element B. This was being done by Bernier. Okay, but it was okay, but there were some limitations also. The different limitations were, though it was a very helpful method because he started up with a very new characteristic of atomic masses and forming of a triads, but there were some drawbacks in this theory because there was no arrangement for all the elements known in the triads. He could identify only a few triads. All the elements were not following this triad formula, so this was not very okay. Then what happened after de Bernier? The next major contribution is of John Newlands. He is an English scientist, and in 1896 he arranged different elements in the order of their. Actually, he arranged about 56 elements were known at that time, and he arranged them in increasing order of their atomic masses. Then he observed that every eighth element was found to have same properties as that of first one. Means first and eighth were having the same properties, second and ninth element were having the same property. Thus, he observed that there was a resemblance in the properties of first and eighth, second and ninth, third and tenth, and so on. Okay. So, according to Newland, when elements are arranged in their order of increasing atomic masses, there is a repetition of properties of every eighth element to the given element. For example, you can see here these elements are arranged in their increasing atomic masses. So hydrogen, fluorine, chlorine, they were showing the similar properties. Same way lithium, sodium, calcium, beryllium, magnesium, calcium. This was the order. They were showing the same properties. This was Newland's law of octaves. Octaves means 8. So every eighth element was showing the same properties if all the elements were arranged in their increasing atomic masses. But contribution was very good at that time. It was remarkable, but it also suffered from certain defects and limitation. What were the defects? Classification was successful only up to the element calcium. After that, every eighth element did not possess the same properties. Same properties were not there after calcium. Okay, like element cobalt and nickel were placed below chlorine, but they are not similar. Okay, cobalt and chlorine, they don't have similar properties. You know that chlorine is a halogen and cobalt is not. Then one more mistake was there in his classification. He placed two elements in the same slot in a particular group. For example, cobalt and nickel in the first group after chlorine. Similarly, cerium and lanthanum were placed after yttrium in the same group. And there were no such explanation to why these two elements have been placed together in the same group. And then he thought that only 56 elements were existing at that time, and no more elements will be further discovered. So this belief was proved wrong because elements are being getting explored each day, so there was no provision for additional elements there. And one more drawback was there, that when noble gas elements were discovered at a later stage, their inclusion in the table disturbed the whole periodic table. Okay, when these noble gases or inert gases discovery was done, then there was disturbance in the periodic table. Okay, so till today we have completed till Newland's law of octaves. In the next video, we will study Mendeleev's periodic table. Thank you.